The significance of these findings is that the time coincides with the development and myelination of the pyramidal neurons, which are the primary excitation unit in the prefrontal cortex. Abnormal development of these neurons is a likely inhibitor to the normal development of the brain, and thus has serious implications for the formation of precise circuitry and consequential normal function. The cerebellum is one of the most important structures in the brain, containing the largest number of neurons and synapses of any structure in the central nervous system. The cerebellum is implicated in motor function and more recently has been found to be involved in higher cognitive functions essential for many of the processes that are compromised in autism, including language and communication, social interactions, stereotype behavior, and motor capabilities. A characteristic finding in the cerebellum of the autistic brain is a significant reduction in Purkinje cells and is seen in about 75% of cases. Purkinje cells are responsible for fine-tuned motor control, balance, proprioception, and communicating information from the cerebellum to the cerebral cortex. Animal studies have also found ASD-like symptoms can be induced by specifically targeting Purkinje cells, suggesting their reduction plays an important role in the neuropathology of autism. Knock-on effects in multiple regions of the cerebral cortex have been attributed to disordered development of the cerebellum. Thus, the multitude of regions and pathways the cerebellum typically forms reciprocal connections to are affected, and are likely to account for the system-wide behavioral deficits seen in autism. Another significant pathophysiological mechanism in patients with ASD is hyperexcitability of circuits involved in sensory, social, and emotional processes. The imbalance between excitation and inhibition of GABAergic and glutamatergic neurons have been shown to increase depolarization of cells for a long period of time in people with autism. GABAergic pathways play important roles in development of an inhibitory cortical system, and the interplay of glutamatergic and GABAergic systems facilitate formation of the cerebral cortex in early development. Imbalance in the ratio between excitation and inhibition is believed to be a potential mechanism contributing to developmental dysfunctions seen in autism, specifically in patterns of information and sensory processing as well as social behavior. Although there is extensive research into the neuropathology of autism spectrum disorder, much more research is needed to comprehensively understand its complex and multifaceted nature in hope of solidifying our knowledge of its developmental path.